night do you sleep?
Not as many as I used to, I'm telling you that. I need more sleep, that's for sure. Okay, let me answer the vitamin C question and the melatonin question separately. So vitamin C, you're absolutely right. Most mammals make their own vitamin C. There have been 3 occurrences in mammalian evolution where that genetic capacity has been lost. There's apes, there's fruit bats, and there's guinea pigs. And the question is, has these animals suffered? Now, of course, we can look at humans and we say, well, okay, humans seem to be living exceptionally long compared to most mammals that do make their own vitamin C, therefore we must have found a perfectly good way of compensating. And that's the right way to look at it. Whenever you look at different species and different situations that different species are in, you've got to take the #1 maxim that evolution is really, really, really clever. And when evolution hasn't done something, there are usually, well, the #1 reason is it couldn't be bothered, or it didn't want to, okay? Very, very occasionally it's because evolution genuinely couldn't do it, but you'd better have an awfully cast iron argument if you want to think that, okay? So, in the case of vitamin C, we know, well, certainly we have every reason to believe that the reason why these occurrences happened was because there was sufficient vitamin C in the diet so reliably that there was just no selective pressure to eliminate the mutations in these genes fast enough to stop them becoming fixed. However, what happened subsequently was, as we see, that these species didn't suffer too much, not only in terms of survival, but also in terms of their increased longevity during subsequent evolution. So this rather tells us that there were perfectly easy ways for evolution to figure out how to compensate for the lack of vitamin C. And of course, only for the partial lack, we do need vitamin C up to a point, but the amount that we get in diet quite easily, it seems to be ample. And the benefits that we get from very large supplementation of vitamin C are extremely equivocal. There are other vitamins for which the biochemical case is better understood. Vitamin E is one. Vitamin E works in the lipid environment rather than the aqueous environment, and we have a much better understanding than we do for most vitamins with regard to how you can have too much of it. How you can basically act as a pro-oxidant, a propagator of free radical reactions rather than an inhibitor of them. With vitamin C, it's a bit more complicated. We don't really know whether that will be true, and certainly it seems that even really, really high doses of vitamin C don't do any harm, but there's been no good evidence that it does significant good. Melatonin is an interesting case because it's a hormone, of course. It's produced, as you say, by the body, and it's produced in a circadian manner. And it's a fine example of what's wrong with hormone replacement therapy at the moment. Ultimately, the endocrine system goes downhill with age in a whole bunch of ways. You get more of some things, less of other things, and it's really bad news. We try to fix this, especially the things that go down, which is most of them, by various types of hormone replacement therapy. But of course, the replacement is done in this very primitive manner, where we just inject a bunch of stuff every day or every month or whatever it might be. And it's completely insensitive to the signals that cause hormones to be released naturally. We can go a little bit of a way towards fixing that by using slow-release things, but still, the slow release is insensitive to what's actually supposed to be the signal. So what we actually need, and this I think is probably not very far away, is implants that respond not only to time, but to actual signals that are coming in, that are actually sensitive to the other hormones, or the temperature, or the amount of light there is, or whatever it might be, that are the signals that the gland naturally responds to. And this would be a shortcut towards remedying the decline, the aging of the various glands that are involved. In the end, that's not going to be the best answer. The best answer is going to be to regrow the gland and get the glands to work right, but we may be able to have a bit of a bridge to that as well.
Gosh, you've got so much knowledge that the answers go on.
No.
I'm trying to fit a couple more questions in, then we should break up. So it's Rand and then it's Stuart.
And I'll be down the pub afterwards as well.
Yes.
Do you think that these therapies could be used to help cryonics patients? And if so, can you get any money from cryonics organisations to do more work?
Okay, so the first part of your question is absolutely yes. I think that the prospect of reviving well-preserved cryonics patients using refinements of the technologies that I'm already working on to keep people alive whose hearts are still beating, that is a very realistic prospect. And at the moment, I'm not saying it's realistic, not saying it's particularly realistic for people who've been cryopreserved already, because even though we have more or less solved the crystallization problem by figuring out how to vitrify people, nevertheless there still remains, first of all, the problem of cracking, and also the, I think, bigger problem of cryoprotective toxicity. But lots of work is going on to address both of those problems, and I am, at this point, pretty optimistic that progress will be fast enough to benefit people in this room, by and large, most of whom won't be dead for the next 10 years. So we can be fairly optimistic there. And for sure, I would be much more comfortable with the idea of being revived that way than being revived in some more non-biological way, shall we say. In terms of your question about funding, yeah, well, cryonics has its own funding problems.
You are one of the advisors to one of
Yeah, I'm on the scientific advisory board of Alcor. I spend a lot of time interacting with Alcor and also with CI. And also with the
The last question to Stuart.
I was wondering, when you were talking about the interplay between singularity and methodology, the singularity you described is quite discrete and benign.
A bit louder?
Yeah, speak up.
Sorry.
Singularity is
have you
discrete and
considered
benign.
the interplay between other people's types of singularities and methodology, and I haven't read any literature by you on that.
You mean about what I think the singularity? Sorry.
Other people's visions of the singularity and how that might link in with the methodology.
Well, yeah, I'm trying to step away from the sort of the splintering of views about the singularity. I'm just sort of trying to keep as general as possible in what I just described today. And that's really as far as I want to go in this, because I think that there is so much unknown. I mean, this point that I brought up during the talk about not even being any significant work, as far as I know, on whether the concept of adequately comprehensive recursive self-improvement is mathematically possible. You know, this is a rather fundamental issue here, and I feel, it's not an area that I have enough time to spend on. Therefore, I'll just sort of keep up to date as best I can on what other people are achieving.
So,
David, can I take 20 seconds?
cutting down.
Right, I just wanted to add something to what we've heard here from these three excellent and enthusiastic presentations. This event is here today is about what happened in New York last weekend. There's one thing that wasn't on the agenda in New York that I think it's important that you all realise happened there, and that was the sense of shared enterprise, the enthusiasm and energy that was created at that event. All the people involved are doing real work in their daily lives, their day jobs, working towards a singularity. There are real people slicing up brains and scanning them and trying to emulate them in silicon. There are real people developing artificial intelligence, real people going out there trying to extend and increase the number of people who are making contributions to our science. This is all happening, it's all happening right now, and everyone in this room has the chance to be involved in it. That's the energy that came from the event that wasn't on the agenda. It's just important you all take away some of that energy from today.